This is Algebra 2, Lesson 12.2. So in this investigation, we're going to take our sine and also our cosine graphs and see what happens with amplitude and with vertical shifts. So I'm going to use my graphing calculator. You don't need one. I mean, you're just going to see what happens on mine. If you have one, you can follow along, but it's not necessary. On my worksheet, it tells me to put sine x plus 1, and sine x plus 2 into the calculator and then graph them to see what happens. So we already know what sine x looks like. We did that in 12.1. So it's a sinusoidal, it's a curve, starts at 0, 0, goes up, back down, back up, forms a complete circle if we were to wrap that around. If I take that sine function and I graph it with a plus 1, and then I'm going to try graphing it with a plus 2, how will that change the graph? So I have my basic graph again, and my sine x plus 1 is actually 1 unit higher. My sine x plus 2 is 2 units higher than the original. So I can add 2, 3, 4, 5. I can add whatever I add to my sine function makes that whole graph go up. I have my traditional sine. And then, let's see if I can do this. Sine of x plus 1 is going to be a little bit higher. And then sine of x plus 2 is going to be even higher. When you add a value to the back, it's a vertical shift. It slides up. Now let's try that with adding a -1 and a -2 instead. So back to my calculator. I'm going to keep my plain sine function on there just to have a reference point. And I'm going to add -1 instead of +1. And I will add -2 instead of +2. And if I graph that, I have my sine function as a reference. And now this sine x plus -1 is 1 unit lower, and sine of x plus -2 is 2 units lower. So that would do the same with minus positive numbers as well. So adding a negative or subtracting a positive, the whole graph slides down. So I'll just do this one regular. But it would be 1 unit down and 2 units down. Whatever we add to the back of the function, positives go up, negatives go down. So my generalization, whenever we add a value here, D is a vertical shift. The whole graph will slide up or down depending on if it's a positive or a negative number. The next one wants me to look at multiplying a value, so I have 2 sine x or 3 sine x. Back to my calculator. I'm going to keep my reference and my reference equation. I'm going to go 2 sine x. Remember, that's the same as 2 times the sine of x. And 3 sine x, which is the same as 3 times the sine of x. So if we want to, we can make a prediction about what we think will happen before we hit graph. But once I hit graph, I see my sine of x. And then my 2 sine of x now got taller, but it also got lower. So essentially the whole graph got stretched vertically, and 3 got stretched even more. We can predict that 4, 5, 6, the higher the value, the higher it stretches. So my traditional sine of 2, 3, oops, that was a loss, but the whole graph gets stretched taller. We can do 4 and 5 kind of the same way. I'll leave 1, but get rid of 2 and 3. There's a 4 sine x, there's a 5 sine x, graph those. And yeah, 4 got really tall, went all the way up to the top and the bottom of the graph. 5's even off the graph because my scale only goes to 4. But if I had zoomed out a little bit, I'd be able to see the top and the bottom of the 5 sign. The sign 5, yeah, never mind, 5 sine x. So stretched even more. Let's try it with some negatives. So -2 sine x and -3 sine x. So my sign for reference, and here is -2. It still goes up to 2 and down to 2, but it's kind of reversed. And up to 3 and down to -3, but again, reversed. So what the negative does is, rather than going up right here, it reflects it down, and then the 2 is going to stretch it because the normal 2 was going up here, and so now the new 2 is reflected down. So the 2 still stretches it, but the negative adds a reflection component. So it is reflected and then also stretched. So this is called amplitude. So the amplitude is the value where a is in my equation, the number in front of the sine or the cosine function, and it's actually equal to 1/2 the overall height. So if I am looking at my graph again, and I'll use this one as an example, the maximum height is 3, the minimum height is -3, 1/2 of 3 minus -3. That's, oopsies, that is 6. Half of 6 is 3. When the equation is centered on the axis, it's a lot more obvious, but if I had an equation that combined vertical shift and amplitude, like 2 sine x plus 1, now I'm looking at that and it goes up to +3, but the amplitude I just put in was 2 because it's not going all the way down to -3. So the maximum height here is 3, the minimum height here is 1, and 1/2 of 3 minus -1, that's 4, half of 4 is 2. And then my vertical shift brings my center line up to +1. So this was 2 sine x plus 1 because my amplitude was 2, but my horizontal center line was at +1. If you have access to a graphing calculator, it makes this really easy because you can kind of guess and check as you go along. But on the exercises, remember, look for your horizontal center. That's going to give you your vertical shift. See how far it is, halfway from the top to the bottom. That's your amplitude. This first question here is just matching. And then we have some graphing, and then a couple where you write the equation for the graph that you see. Please let me know if you have any questions, but that is it for the notes.